Hello and welcome to my channel again. Today we have Volkswagen GTD it's Volkswagen Golf GTD 2016, and the vehicle has come to our garage with the engine management light illuminated on the dashboard, plus some airbag light too, and the vehicle is producing this type of smoke, and the fault code is related to the mass airflow sensor. It says the mass airflow sensor out of range. The mass airflow signal is out of range. So because I have played with the vehicle a little bit, and I have created another fault code as well, but I scanned the vehicle when the vehicle came first, and I have saved the report, and now I'm going to show you the report, what is in the report. I'm going to scan the engine control unit again, and after that, after seeing the or after checking the treble code, I'm going to show you the report as well that I have saved when the vehicle came first. So mass airflow sensor, a circuit range performance. This is the main fault code that we had at the beginning, and also this too as well, this one as well, sensor for internal pressure of cylinder 3 electronically. So this I have created this. So let me show you the report that I had when the car came first into our garage. So this is the report. See, it says engine management, engine control module, 2 faults. If you see, let me go to the fault code detail. This was the fault code. I retrieved from the vehicle when the vehicle had came first. So it says mass or volume airflow sensor a circuit range performance. So this is the second one, which is sensor for internal pressure of cylinder 3 implausible. So these are the main fault codes I have. So now I'm going to take value of the mass airflow sensor and compare that with the manufacturer specification. So and see whether that can match the manufacturer specification, or it cannot match to the manufacturer specification. So our focus is on this fault code, P010100. Okay, this is the wiring diagram, and this is the mass airflow sensor. So we are going to check 2 wires, one at pin number 1, which is the supply voltage of the mass airflow sensor, or power supply to the mass airflow sensor, and wire number 4 or pin number 4, which is the signal wire for the mass airflow sensor. And as you can see, this one is connected to pin 80 at the engine control unit, and also the connector name is B connector. So first we are going to check the supply voltage to the mass airflow sensor, and then take measurement. So what measurement should we take? Now I'm going to show you that what measurement should we take. So at the sensor we are going to backproof the pin number 4, and that's going to be connected to the engine control unit at pin number 80 connector B. So this is the pin data. So we are going to test the mass airflow sensor's supply voltage at connector at pin 1. So we are going to connect the oscilloscope red lead to pin number 1 and the black lead to arc, and the connector will be disconnected and the ignition will be on. We should have 11 to 14 volts, and this is as it says that checking supply voltage test at harness multiplier. So when we check that, then we will go as I have shown you that. So B12 is the earth wire or the signal or the ground wire for the sensor. So I'm going to show you here. This is going to be B12 and pin number 2. So this is going to be the ground wire for the mass airflow sensor. So and this wire is connected at pin 12 connector B at the electronic control unit. So pin 2 should be with the ignition on 0 volt, and as I told you, B80, which is pin number 4 at the sensor, and pin number 80 at connector B at the control unit, engine control unit. So with the ignition on, we should have 1870 hertz of frequency. So we should have 1870 hertz frequency. So after that, we are going to start the engine, and at the same pin, at the same connector, so pin 80 connector B at the engine control unit, we should have 2590 hertz with the engine idling. So we are going to check that at the sensor itself, or in another words, we are going to put this theory in practice. Okay, at the sensor, this is pin number 1, and this is pin number 2, and this is pin number 3, and the last one, the green wire, is pin number 4. So pin number 1 is the supply wire, power supply to the sensor. So we are going to disconnect the sensor first. So I'm going to disconnect sensor first. Okay, now I'm going to turn the ignition on. So ignition is on now, and I'm going to backproof this one. Actually, I do not need to backproof this one, so I'm going to check it here. So this is pin number 1, and I'm going to volt DC. As you can see, it's battery voltage or source voltage 12.61. So it's pin number 1 at the connector. Now I'm going to check pin number 2. Pin number 2. So I have connected the back probe to pin number 2, and as you can see, it's 0.01. So now I'm going to connect the connector, or put the connector back on. So now I'm going to check the signal voltage or the signal frequency. So I'm going to back probe the this is, as we previously saw, that this is pin 4 at the connector, and this is connected to pin 80 at the connector B at the engine control unit. So now this is connected and the ignition is on. So I'm going to show you, bring the voltmeter back to measure frequency. So okay, with the ignition on, we have 1856.4. So we have 1856.4 hertz of frequency, and the manufacturer specification was 1870 hertz. So a little bit different, but I'm not sure. So this is the actual value, and this is the manufacturer specification. As you can see, ignition on, we should have had 1870 hertz, but right now we have 1856.4 hertz per second. So now I'm going to start the engine and see that what figure or what type of frequency per second we will have. So I'm going to start the engine. I have started the engine. As you can see, engine is running, and with the engine idling or engine running, and we have 2205.9 hertz per second, and the manufacturer specification is that engine idling we should have 2590. So this is 2205. So there are approximately 300 hertz or frequency difference between the actual value and the manufacturer specification, which is this one. So the manufacturer specification says that engine idling 2590 90 hertz or frequency we should have per second, but here this is the actual value we have. Okay, as you can see, the engine is running smooth at idling. And another thing I'm going to add that the customer said, so 1 week before the problem occurs, I took the vehicle to a garage, and the garage put GTD cleaner into the exhaust system and cleaned the exhaust, and the vehicle improved. There was no problem, but after 1 week the problem has started like this. The engine has no power, and as you can see, the vehicle gives this type gray smoke or white smoke, whatever you call it. It's going to be gray smoke, not white smoke. And let me rev the engine. So when you rev the engine, it's not rev. See, it's not going about 2000 RPM. So, and this is the smoke that you can see. And it's, I think it's raw fuel. It's raw fuel, but okay. I suspect that the EGR valve could be stuck open, the inlet manifold, and the inlet port might be clogged. The DTF could be clogged, or timing issue could be too. That everything has to be considered. So first, I'm going to start with the inlet manifold. So I'm going to remove the inlet manifold. I'm not going to remove that in front of the camera or recording this one, but I will show you when I remove. I will show the result of that, whether it's clogged or not. Then I'm going to check the EGR valve in case the EGR valve is stuck open. Then I'm going to check the GTF condition, whether it's blocked or not. So finally, if there was no any issue in these things, so inlet manifold, EGR valve, GTF filter, diesel particulate filter, then finally I'm going to check the timing. So stay with us, and let's see if we can fix this car. So revving again once, and this is grey smoke, completely grey smoke. Accelerator pedal is fully pressed down. One thing I hope I should have mentioned that before. I should have mentioned this before, that the mass airflow sensor is changed as well, because as you can see, this is Bosch box, but the Bosch mass airflow sensor is right now on the vehicle. It's installed on the vehicle, and this is I think it's the old one. It's the one which was already on the vehicle when the vehicle came from the factory, and this is the one that replaced as you can see, this is the mass airflow sensor, which is newly installed, and this one is the vehicle original mass airflow sensor, where the vehicle come from the manufacturer or from the factory. As you can see, it has Volkswagen and Audi Mark II. Okay, as you can see, I have removed the EGR valve, and this is the EGR valve. Just let me hold on. This is the EGR valve port, and this is the entrance going to the inlet manifold. If you can see this hole, that's exactly here, that is here, and I'm going to show you that in the camera. As you can see, that's the hole, and that's the EGR valve bore itself, as you can see. And this is the inlet manifold, and also this is the throttle valve or throttle body with the bracket, this one. But actually look at this, look at this. I'm not sure whether it's completely clogged or I think the EGR valve is going to be completely clogged. So anyway, you can see, I think this is blocked, clogged, completely clogged. Even if the EGR valve operates, this is not going to allow exhaust gas to go to the inlet manifold. So anyway, I'm going to clean that. So this is the amount of carbon which I have taken out. From here. Now I'm going to vacuum this carbon belt here. I have just found that the intercooler or air cooler, the radiator or office is completely blocked inside. If you can see, look, it's completely blocked. But I don't know the structure of the inlet manifold, whether the air passes through this orifices of the air cooler, or there is different orifices for the air to pass to the inlet port or to the inlet valve. But as I can see here, you might be able to see that this is completely blocked. The radiator is completely blocked. If the air passes through this, look, I'm going to show you. Look, it's completely blocked. So if the air passes through this, if the air passes through this radiator type, this, and then that's going to be completely blocked. As you can see, it's completely blocked. Look, it's completely blocked. Okay, I have removed the inlet manifold or the intake manifold. There is two down. So one is here, this one, and the other is over there, this one. Stay this one. When you installing, that should be properly aligned. Two dowel pin here. And now I'm going to show you inside of the inlet manifold. So look, it is completely blocked. Completely blocked. Look, the radiator or the intercooler or office is completely blocked. Now I'm going to turn this way. Look here, I'm going to show you the EGR exhaust gas recirculation or offices. Only one is open, the rest. So this is completely blocked. This is also blocked, and this one is also blocked. So this is the radiator that can be seen from this side, and unfortunately this intercooler or charged air cooler, it's too dirty. No. That the scratches can be seen, that I have scratched the carbon belt sluggish. Look, it's completely blocked. So now I'm going to soak this for 24 hours in the DPF cleaner solvent or fluid. Then tomorrow I'm going to thoroughly clean this. Okay, I'm going to show you through the camera, scope camera. Can you see this is completely blocked? I'm going to move camera down to the end. Not sure. Oh, this is the camera touches the carbon. Look. To the end. It's completely blocked. Oh, the camera touches the carbon and it's blocking the camera. Look at that. It's the same to the end. It's completely blocked. You can see the sluggish. Even if I hold, no way, no way, no way. If I hold this, I'm going to hold the light underneath there and then look from here. Nothing can be seen, no whatsoever. So I'm holding light underneath there, so no light can pass through the radiator or offices. Look, I'm going to no light can be passed. Okay, I'm going to put solvent here, but as you can see, it's barely coming out here. Look. Okay, as you can see, I have soaked the inlet manifold in the degreasing liquid since yesterday, and the liquid has completely turned to a dark black liquid. So today I'm going to clean that thoroughly out and install that and see if we can fix the problem. Okay, and let me put some liquid here. Oh, I'm not sure. The liquid still remains and stays here. Okay, now okay, as you can see here, yesterday when I dropped liquid here, it stayed here. Today, fortunately and luckily, the liquid drains down. So as you can see, and it has been cleaned. Good news. This is good news. Yesterday when I dropped the liquid here and it stayed here to clean the EGR or offices completely, like so. Okay, now we are going to rinse with water. As you can see, now it's completely clean. Look. Okay, now we have put everything together. We have thoroughly cleaned up the inlet manifold, and we have put everything together. Now we are going to prime the fuel system with the scanner, and then we are going to start the engine. After starting the engine, we are going to take the value of the mass airflow sensor and see if that can match the manufacturer specification. Okay, now we are going to take the data of the signal wire, and with the ignition on. So with the ignition on, it's going to be 1870 hertz, and with the engine idling, it should be 2590 hertz. So this is the data which we are going to take from the pin number 4 at the mass airflow sensor connector. So we are going to back through pin number 4 at the mass airflow sensor. So as you can see, so with the ignition on, it's going to be 1870 hertz, and with the engine idling, that should be around 2590 hertz of frequency, and this is going to be the input signal to the ECU from pin 1 or from the signal wire at the mass airflow sensor or from the mass airflow sensor. Okay, as you can see, now the ignition is off right now. We have no any frequency or any hertz at all. Now we are going to turn the ignition on. Okay, as you can see, with the ignition on, we have 1856.4. So I have to mention that because this is the aftermarket mass airflow sensor installed, this might not reach the specification of the original manufacturer equipment. So as you can see, with the ignition engine off, we have 1856.4 hertz. Now we are going to start the engine. So we have started the engine. Engine is running. As you can see, we have 2259, approximately 2205. It's fluctuating. 2205. The manufacturer specification is 2590, but here we have got 2205. But this is aftermarket mass airflow sensor. And now I'm going to show you that the engine management light is off. Okay, as you can see, we have no longer mass airflow sensor fault code. As you can see, these are the fault code because one is for the steering angle sensor, that is because the battery was disconnected, and the other is cylinder 3 glow plug circuit, as I have shown you that the connector is broken, and also the second fault code, which is P010100, and that's also for the cylinder internal pressure, and because the cylinder number 3 glow plug and the pressure sensor for the internal cylinder pressure, cylinder number 3, both are integrated. So the sensor for internal pressure of cylinder 3 connector is also broken, so this code is for that. So when we fix that connector and put a new cylinder number 3 sensor, that's going to be all right. So we have fixed the mass airflow sensor performance. I think it was so it was here. So I'm going to go to the report, and I'm going to show you that Volkswagen, that was this one. Engine control module, it was this one actually. It was P010100 mass or volume airflow sensor A circuit. Okay, we have fixed the problem. As you can see, the engine speed is approximately at 50, but there is a vehicle in front of us. We cannot go more than this. And as you can see, the engine management light is off, and the vehicle or the engine has a proper power. That's a good news. As you can see, the vehicle speed is at 60. This is a good news, and the engine management light is off. So we have fixed this problem.